we're going to start studying relations and functions. Now, you studied this particular function in depth in Algebra 1. The line, it has many characteristics, and we are going to see how a lot of what you learned in Algebra 1 applies here in relations and functions. The first thing we're going to talk about is what is a relation. It is literally a relationship between two values, our input and our output. Now, to be organized, we're going to label our input as X, and our output we're going to call Y. So this is an example of four ordered pairs that are going to represent our relation. In the first one, our X value is -3, our Y value is 4. In the second ordered pair, the X value is 3, the Y is -1. In the third ordered pair, the X is 4, the Y is -1. And in the fourth order pair, the X is 4 and the Y is 3. Another way we can represent relations is with a table of values. Now, to make a table of values, you take each ordered pair and you break it up. You put your inputs, your X values, in the left-hand column. You put your outputs, your Y values, in the right-hand column. And each ordered pair gets a row. So the ordered pair -3, 4 translates to this table of values, -3, and then in the second column, 4. And you can see each one of these gets their own row. So if you have 4 ordered pairs, you will have 4 rows of data in your table of values. Another convenient way to represent relations is with a mapping diagram. Now, for a mapping diagram, what you want to do is go in and select all of the X values. And in this case, we have 3, 3, 4. Now, this 4 is repeated, so we're only going to list -3, 3, and 4. We're not going to put duplicates in our input column. And we're going to do the same for our output column. We have a 4, 2 -1s, so we're just going to list 1 -1, and a 3. Now, to show the mapping, we're literally going to map our input to our output. So -3 maps to 4. So you'll take an arrow and take it from -3 and map it over here to 4. +3 maps to -1, so +3 maps to -1. And 4 maps to -1. And this last one says 4 also maps to 3. So a mapping diagram will look like this. And the last way we represent relations is with graphs. For a graph, you go in and plot your input and your output. I tend to like either one of these two representations to help me with the graph. You try this one since I've marked on it. The first point is -3, 4. So you're going to come over -3 units. So you're going to go back 1, 2, 3, and then up 4. So this is the point, -3, 4. The point 3, -1 means you're going to come over here 3 to the positive side of X, and then down 1. So this is 3, -1, -1. The point 4, -1, you come over 4 and go down 1. So this is 4, -1. And the last one is 4, 3. So you're going to come over here to 4 and go up 3. So when I ask for the 4 ways to represent a relation, I want to see an ordered pair, a table of values, a mapping diagram, and a graph. So let's see what a problem would look like. Suppose I give you a picture like this, and we have a skydiver who is jumping out of an airplane, and it looks like the data is kind of all over the place here. And suppose I want to represent this relationship using 4 different representations. Well, let's see. first thing we need to do is gather the data. It looks like he jumps out of the plane at 0 seconds and he's at 10,000 feet. At 4 seconds, he's at 9,744 feet. At 8 seconds, he's at 8,976 feet. And on down to 16 seconds. So we have 1, 2, 3, 4, 5 data points. So for a mapping, we're going to do, what are our x values? Well, the first one is 0. The second one is 4. The third one is 8, 12, 16. So this is going to go into our box. So this is our input. And it's going to go to our output. Let's see, of 10,000. Um, 9, 7, 4, 4 feet. And all I'm doing is pulling the data at this point. 8, 9, 7, 6 feet. 7, 6, 9, 6 feet. And 5, 9, 0, 4 feet. And this is our output, and we're going to put this in a box as well. Let me switch pen colors here. Now our mapping, 0 maps to 10,000 feet. 4 maps to 9,744. 8 maps to 8,976 feet. 12 maps to 7,696 feet. And 16 maps to 5,904 feet. Now, yes, for completeness sake, I do need to have my seconds on here. I got a little sloppy there. Sorry about that. Now, suppose I wanted to do ordered pairs. To do ordered pairs, I've already got, let me change my thickness here. I've already got it lined up this way. So my ordered pairs will be, I can just read these off, 0, 10,000. And usually in ordered pairs, I'm not going to put the units. So I'm reading each one of these mappings off as an ordered pair. Now, what if I wanted to make a table of values? Well, to make a table of values, you want to start with your x, y, go on and label them. You can call them input and output. Now I'm going to go ahead and list my x values. And I'm going to put my units up here. It makes it a bit easier. Now I'm going to put in the y value that corresponds to each x value. This is a little tedious, but so we see how these three correspond. The last way we can represent these is with a graph, and I went ahead and just had a graph done. You see I had to break this a little bit, and that's really okay. Otherwise, the graph would be a tiny part of the entire representation, and we want as accurate representations as possible. So, 4 ways to represent one relation.